Good afternoon, everyone. Thank you for having me here today. My name is Huyen, and today I will be presenting our research on integration of Tuyet and machine for saltwater intrusion forecasting in Ho Chi Minh City, Vietnam under climate change. My presentation is structured into four main parts. Now, let's talk about what salinity intrusion is. To simply understand this, it happens when saltwater flows into fresh river system. Saltwater causes many bad effects. Its forming causes health problems like high blood pressure and damaged building. Not only that, it also impacts on many other aspects. Ho Chi Minh City is particularly vulnerable because it sits on a land with complex canal system, especially during the dry season. Now let's look at the map to see how saltwater affects Ho Chi Minh City in the dry season. As you can see, when we don't have enough fresh water, our water system faces big problem. First, it's very hard for water plants to work. For example, right here, the Tuyet water plant in Hóc Môn cannot get clean river water. Over here, Tuyet big plant in Thủ Đức also face many difficulties in making drinking water for the city. Second, when the dry season lasts too long, saltwater goes deep into the land. It causes a lot of trouble for farming and daily life of local people. Although many physical models have been applied, they still have some limitations. Most importantly, they struggle to capture the nonlinear relationship between salinity and hydrological factor, which is a gap our study aims to address applying machining and deepening. Many studies in Vietnam and globally have shown that machining and deepening work well for forecasting intrusion. These students are the foundation for our research with three main objectives. The first, to analyze partial water intrusion trends in space and time for the periods from 2008 to 2024. Second, to build the saltwater intrusion prediction model based on long-term memory and random forest algorithm. And third, to forecast saltwater intrusion for the periods from 2025 to 2035, both spatially and temporally. Our methodology begins with collecting input data covering dam, river network, salinity, rainfall, tide, and temperature from 2028 and 2024. This data goes through processing steps to ensure all input data are high quality, consistent, and ready for modeling. Next, we then apply Pearson and correlation and maximum information method to identify the most relevant input variable. The data is split into training and testing data tests. Then we build model based using both random forest and long-term memory algorithm. Each model goes through training and validation with adjustment until testing confirms good performance. We then compare performance using 4 metrics to select the optimal model. Finally, the optimal model is used to forecast future salinity for the 2025 to 2035 period. And the result. Regarding the trend of salinity over time, the study applied 2 methods: innovative trend analysis and seasonal trend analysis (ULOS). The IES method showed a decreased trend of salinity at all stations, but this trend was only statistically significant at An Hà, Cát Lái, and Thủ Thiêm station. Besides that, the HDL method revealed the distant seasonal fluctuations so-called at all stations, with higher salinity during the dry season and lower during the rainy season. The amplitude of seasonal fluctuation gradually decreased when moving inland from Nha Be and Ong toward Thủ Thiêm and Ong Ha Station. According to spatial change, in 2008, salinity level were relatively low to medium. However, by 2011, it has significantly increased with a bit of 13.9 per mil recorded. Saltwater intrusion became more severe in 2016, with salinity level peaking and spreading throughout the entire river system, affecting both coastal and inland areas. By 2024, although salinity has slightly decreased, it remains far higher than the level recorded in 2008. Moving to the evaluating model, with overall performance at 5 out of 6 stations being equivalent and superior, long-short memory has shown a better ability to capture trends than random forest, especially at times of unusual fluctuation, typically expressible in Ong Ha Station. In contrast, at stations with high level of stable of line data like Nha Be Station, random forests show better capture ability with NAS circuit efficiency with the testing periods of 0.86 compared to 0.81 of ability long-short-term memory. These results confirm that long-short-term memory is more effective in handling complex salinity fluctuation, while random forests remain reliable under stable conditions. Regarding spatial capture, while random forests underestimates salinity and fails to identify the enter high-risk zone, long-short-term memory not only predicts higher value but also localizes affected areas more accurately. Therefore, long-short-term memory is selected to predict saltwater intrusion in Ho Chi Minh City. In the future, long-short-term memory show that deep inland stations such as Ong Ha and Thủ Thiêm have salinity fluctuating at low to the medium levels, whereas stations closer to the sea maintain higher salinity level, with maximum value reaching about 3 times those of the inland station. In particular, from 2025 to 2029, salinity tends to spread rapidly, spreading deeply inland. By 2033, salinity will peak a second time, but mainly concentrated on the coastal area, rarely spreading deep inland. After 2033, salinity tends to decrease slightly. The prediction highly the growing threat of saltwater intrusion under impact of climate change and provide important scientific evidence, helping water resource managers develop effective adoption strategies for Ho Chi Minh City. At the same time, increased salinity also causes serious damage to its ecosystem. When the saltwater-freshwater boundary shift, the entire food chain is disrupted. Freshwater species decline due to salinity drop. Moral forests in the Kieu are become stunned in biodiversity is reduced. This is the summary of the study. Despite these promising results, the study has some limitation including limited input factor and only detected general change. So the next study should focus on incorporating more variables, both natural factors such as upstream water flow and artificial factors such as dam construction, as well as integrating climate change scenarios to improve forecast accuracy and reliability. And thank you for listening.